Okay, so we want to think about how we can find the sine of double an angle today. So for instance, if we have an angle that is sitting in the first quadrant, so theta would be here, and we want double that angle, that means we have to go from the x-axis first here, and then we want to go the same distance, so approximately here, and find the new sine value. So we know from the unit circle that our sine is the y value if the radius of the circle is 1, so this would be sine of theta over here. So same thing over here, if I drop down an altitude, my radius is 1, my sine of theta is now the height of this purple triangle. So we want to figure out a formula to use just our original angle value to find the sine of double that angle. So our last lesson talked about the sum and difference formula. So we had, for instance, sine of x plus y equals the sine of x times the cosine of y plus the cosine of x times the sine of y. So if we think about that, to get double theta, if I plug in theta for both x and y, theta plus theta would be the same thing as 2 theta. So we can use this formula to help us figure out the sine of double an angle. So if we go ahead and just plug into our formula, we have then sine of theta times cosine of theta plus cosine of theta times the sine of theta. Well, now we know from the commutative property of multiplication I can just switch the order if I'm multiplying two things together. So now I can write this as sine of theta times cosine of theta plus sine of theta times cosine of theta. Well, I have 2 sine of thetas times cosine of thetas, so I can rewrite that as 2 sine of theta times the cosine of theta. And that is our formula to find the sine of double an angle. So that's a formula we need to know. So now we're going to see how we can use that in action. So our first example asks us to find the sine of 2x if x is in the third quadrant and sine of x is negative 6 over 11. So I'm going to go ahead and draw my quadrant. So I'm over here in the third quadrant, and I know from a reference angle that my x value, my angle, goes inside the corner by the origin. And then sine is opposite over hypotenuse, so we know that this is negative 6 and 11. So we need to figure out how to plug into our formula. So from our last slide, we know that the sine of 2x, or sine of 2 theta, is just equal to 2 times the sine of x times the cosine of x. Which means in order to plug into this, I need to know the cosine of x first, which means I need to know the value of cosine from this triangle. So since we have a right triangle, we can use Pythagorean theorem. So I know that negative 6 squared plus, we'll call it, I don't know, b squared, since that's another side of the right triangle, equals 11 squared. Negative 6 squared is 36, plus b squared is 121. If we go ahead and subtract 36 from 121, we're left with 85, so b squared equals 85. Taking the square root of both sides to get b by itself, we get b is equal to the square root of 85. Now if we stop and think if we can simplify that, 85 cannot be divided by 4, 9, 16, or 25, or 36, which means that we can't reduce that square root at all. And then we want to think about what quadrant we're in. So if I put a root 85 here, I know that I'm in the third quadrant, which means I have to have a negative cosine value. So I'm really going to make this the negative square root of 85. Okay, so now we have all the numbers that we need, and we're going to go ahead and plug in. So going over here to our formula, I'm going to go the sine of 2x is going to equal 2, and we were told the sine of x was negative 6 over 11. And using my right triangle now, I know cosine is adjacent over hypotenuse, so that's going to give me a cosine of negative root 85 over 11. I'm going to put my 2 over 1 so I remember how to multiply my fractions, numerator by numerator, denominator by denominator. So I'm going to get negative 12, 2 times negative 6, times negative square root of 85 is going to make it all positive. So we have 12 times the square root of 85, and 11 times 11 is 121. So our sine of 2x value is 12 root 85 over 121. So, of course, if we can find the sine of 2 times an angle, we can also go ahead and find the cosine of 2 times an angle. So very similarly, we're going to use our cosine of x plus y formula. So remember that was cosine of x times cosine of y minus, because it's opposite of the symbol in between the angles, the sine of x times the sine of y. So again, if I want 2 theta, I can break that down as cosine of theta plus theta, which means I'm going to have cosine of theta times cosine of theta minus sine of theta sine of theta. So cosine times cosine, that's going to give me cosine squared of theta minus sine squared of theta. So that's going to be cosine of 2 theta, of course. So this is one formula that we can use to find cosine of double an angle. Now, it's been a really long time, so you might not remember this identity, but we know from the beginning of trig that cosine squared of an angle plus sine squared of an angle is always equal to 1. So if we rearrange that, we have 2 different identities coming from that. If I solve this for cosine squared, I'm going to get that cosine squared of theta is really 1 minus sine squared of theta. Or I can rearrange it for sine squared and get that sine squared of theta is equal to 1 minus cosine squared of theta. So we're going to use these 2 different variations of the Pythagorean theorem identity to rearrange this cosine of double an angle formula to get other variations. So if I plug in for cosine squared here, so I know cosine squared is equal to 1 minus sine squared of theta. And then I'm going to subtract the sine squared of theta that was from my original formula. So that's going to give me, I have 1 minus sine squared is minus 2 sine squared of theta. So that's another variation we could use. We can also go back in and plug in for sine squared of theta, which would give us cosine of 2 theta equals cosine squared of theta minus our variation on sine squared is that sine squared is the same thing as 1 minus cosine squared of theta. Now we have to be careful with this negative symbol, so we're subtracting the 1 and we're subtracting negative cosine, which is going to give me cosine squared of theta minus 1 plus another cosine squared of theta by distributing the negative. So that's going to leave me with 2 cosine squared of theta minus 1 as my third formula variation for cosine of double an angle. So you can use any of these 3 formulas to get an answer, and if you plug into all 3, you should get the same answer for all 3. We really have 3 formulas for different reasons, so depending on what you're given at the start of a problem, that might make it easier to plug into one of these variations over another, but if that's too much for you, just pick one of them to remember, and then just always plug into that one. So again, we're going to go through an example of how that works. So we want to now find cosine of 2 times x if x is an angle in the first quadrant. So go ahead and draw my angle into the first quadrant. And cosine of x is 1 over 3, so cosine is adjacent over hypotenuse. And again, just like our last example, we're just going to go ahead and practice finding the sine value. So we need to find this letter here. I'll call it a for this one. So we know that 1 squared plus a squared equals 3 squared by the Pythagorean theorem, which means 1 plus a squared is equal to 9. Subtracting 1, a squared is equal to 8. And again, we take the square root. And since we're in the first quadrant, we're going to get a positive answer because sine is positive in the first quadrant. So we have a is equal to the square root of 8. But we know that we can rewrite 8 as 4 times 2. And if we take the square root of 4, a is going to become 2, bringing the 4 out, times the square root of 2. So this a value is really 2 root 2. And we're going to plug into all 3 variations of cosine of 2 theta just so you can see how they all work and how they all give us the same answer. So we're going to plug into the first one we found first. So cosine of 2x equals cosine squared of x minus sine squared of x. So we were given that cosine is 1 over 3, so we have 1 over 3 squared minus, using our formula here, we have 2 root 2 over 3 all squared. So 1 over 3 squared is going to be 1 over 9 minus, remember, 2 root 2 is actually the square root of 8, so if I square that, I'm going to get back an 8 over 9. And if I subtract, 1 minus 8 is going to give me negative 7 over 9. So using our first formula, we get negative 7 over 9. Now we're going to plug into our second formula and see if we can use that one. So our second formula variation for cosine of 2x was 1 minus 2 sine squared of x. So plugging in, I'm going to get 1 minus 2. Sine squared of x is 2 root 2 over 3 squared. So that's going to give me 1 minus 2 times 8 over 9. So now if I go ahead and multiply that by 2, remember it's 2 over 1, so we're going to get 1 minus 16 over 9. Now in order to subtract fractions, I need a common denominator, and here it's going to be 9. So I'm going to rewrite that 1 as 9 over 9 minus 16 over 9, which again gives us negative 7 over 9. So good, we got the same value, and now we're just going to check it for the third one. So plugging into our third formula, which is said that cosine of 2x is 2 cosine squared of x minus 1, is going to give us 2 times 1 over 3 squared minus 1, which is going to give us 2 times 1 over 9 minus 1. Multiplying that first fraction by 2, I'm going to get 2 over 9 minus 1. Again, I'm going to rewrite 1 over 1 as 9 over 9, so I have a common denominator. 2 minus 9 is again negative 7 over 9. So all three formulas produce the same answer, so it doesn't matter which one you use. Now, if we were looking at this problem and analyzing it from the get-go about which one would be the easiest, I would use this last one because the problem gave me the value of cosine of x, which meant without solving for anything additional, so I didn't actually have to solve for sine of x here, I could have already plugged into this formula at the bottom and found my final answer that way without doing any extra work. Okay, so you have two OYO problems now to work on. So the first one says if cosine of x is 5 over 8 and cosine is in the second quadrant, so whoops, that should be negative 5 over 8, my apologies. You want to find sine of 2x and cosine of 2x. And then I want you to try and use a double angle formula to express cosine of 4x. So try and find a formula to find cosine of 4 times an angle.